Do you see the link?
Yeah, I got it.
Okay. House OBS. Perfect. Alright. You can either follow me through slides or uh, through Twitch, however you prefer. Okay, let's get started. So today's topic is arrays, collections, loops, and logical statements. So first let's cover logical controls. The most basic logical control is if. Why do we need something like that? It's needed because we want to implement um, a flowchart in our code. We don't want code, we often don't want code to be linearly executed. We want to execute it based on some conditions. And that's why we use if statements. And basically how they work, if some condition is true, your code will run. Else it will simply skip that part, which you wrapped with an if statement. And here are basic operators, not basic but all if operators, for negation, for comparison, and for combining conditions. So the most trivial case, like I said, you simply write if condition and you put code which you want to execute when your condition is true. Note that condition is true, you compare it to true with double equal signs, and also note that uh, you don't need comparison if it's true when the value is already an expression. Condition, which is a Boolean variable, doesn't need to be compared second time to be true or false, because uh, essentially you're saying if condition is true, then evaluate it, because you will run something which is true always. So that's why you don't need a second comparison for the true. Um, because true, you would essentially be saying if true equals true, and that's always true. That's why no second comparison. All right. And for one line uh, 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 code blocks which you need to execute, you don't need brackets, though it's recommended to add them anyways. As long as you stay consistent with the way you write your if statements, then it's good. Now we have another way of writing if statements, basically the same thing except multiple conditions. So multiple cases, and we stack those cases with an else statement, else if. So if some condition is true, we will execute the code when it's true. Else if another condition is true, we will execute that piece of code. And we can stack it infinitely. Um, Quite simple. And last thing that if has, it's simply if some condition is true, then you execute some code, and then in all other cases you execute other code. So in this case, one or the other will run. Never both, and never neither. Now, an interesting thing which confuses many people quite often is the end with two end symbols as opposed to end with one end symbol, uh, um, and same with OR symbol, with two OR symbols or one OR symbol. Two AND symbols and two OR symbols is called short circuit or short circuit AND. It's because it will stop immediately after uh, a condition will evaluate to the value which would stop, which would mean that it would be impossible for the overall expression to be true. In other words, when it's AND, if left side is false, there is no point to evaluate the right side, because false and anything else on the right will give false always. So AND with two symbols will stop after evaluating the first side if it evaluates to false, and for OR uh, it will stop on if the first side, if the left side is true, because true or anything is still true. True or false is still true. False or false would be false. Only them. Alright? So the difference, in other words, is that AND with one sign will evaluate both sides, even though evaluating one side would be enough. And AND will work more optimally, and it will evaluate only single side if it is enough to determine if the whole expression will be true or false. Why do we need switch statements? What is a switch statement? It's an alternative to if. We have logical statements based on specific values. So instead of some condition in general, you would have specific values which would determine which piece of code you execute. So that's the difference. Well, you can do the same with if, but it would be more readable if you do something based on values with a switch statement. Alright, so the example looks like this. You have some value, let's say int is the value of type int, so you check if int value is 0, you execute that piece of code, and you stop checking other cases with a break statement. That's the way that switch tells to stop, not check other conditions, and it makes sense because if you wouldn't put a break there, it would mean the same as if value equals 0, do this, and then if value equals 1, do this, which will never be the case because value cannot be at the same time 0 and 1. So checking it twice for different values is not needed, and that's why you break it with the break. I forgot to put the break on the case 1 statement. I should fix that because the case 1 will check if it's true. Case 1 meaning value will be checked if it's equal to 1, and even if it is 1, it will still check for default because I didn't put a break statement. Alright. So, do you have any questions about conditionals?
No, not me.
Okay. Let's continue. Back to the point about AND with one sign and AND with two, like double AND. Were you aware of it, of the difference? Maybe. Okay. So let's move on to the next part of today's lesson is how to store many of the same type. First, most basic way of doing it is array. Um, Arrays have a fixed size and they're used to store uh, many variables of the same type into a single variable. Uh, so basically how it works, you define an array with brackets. Uh, um, I don't know the English name for those brackets, but you can see in the example. And then you create a new array by assigning memory to it, by specifying amount of elements which that array will carry, and then you can work with it. So in this example, we create an array of 10 elements. Those 10 elements will have default values. For int, it's 0. And to access an array, we need to use some sort of an index. Index for all collections except hash except hash-based collections. I mean a hash map or dictionary. So all collections except those will have int as an indexer, uh, and other collections can have any type of variable as an indexer. So in this case it's int because it's array, and by passing a number, a positive number, more like a non-negative number because 0 is neither. Square brackets. Okay, true. Right, so to access the first element of array in C#, you use 0. So you put 0 in between square brackets right next to the name of array, and you'll access the first element of array. And then you can do whatever you want with it, like setting a value, converting to string, and so on and so forth. And to get a number of elements in the array, you have length property or field. I'm not sure if it's field or property. Probably property. I really hope they made it as a property. Though for optimizations reasons it could be a field. Yeah. Maybe a field. Most likely a field. Alright. So that's array. It's quite simple. Arrays can be two-dimensional. They can be jagged. The difference between jagged and two-dimensional array is that jagged arrays are split with a comma, and it basically means it's a matrix. 2D array means it's an array of arrays, and it means that the dimensions can be different, like for different elements of array, which holds other arrays. So it means, let's say, if I have a 2D array, I'll give an example written a bit later because it's hard to explain about 2D arrays with words only. But the difference between jagged array and normal and 2D array is that jagged array is um, with strict dimensions, and those dimensions don't change for every element, and for 2D array each row can have its own dimensions. Right, now let's move on to next very common way of structure of storing many of the same type. So it's a list. It's a generic structure which does pretty much the same as array except quite differently. It probably has an array under the hood. I mean, it has to have an array under the hood. And the thing about this compared to an array is that array is fixed size, and if you need to expand an array, you will have to create a new one, copy elements of the old array, and transfer it to the new one. Expanded array. That's how you add elements to array when it's above its size. For list, it's automatic, and you simply add elements to a list with a method, with an add method. Uh, so the key difference between list and array is that you manipulate list through methods and not directly, like in array. For example, if you create a new list, um, and you say that the 0th element of a list is 1, then it will give you an exception, because a list uh, which is created initially, it will not have that first element. You need to add it first in order to change its value. So that's the key difference between key differences between list and array. It's expandable and it's manipulated through methods. Also, it has, since it's a structure, it's not a primitive, it has more utility methods. Like you can clear elements of the list, you can copy a list to another list, you can add a range of elements to a list, and so on and so forth. So it's a really useful thing. A rule of thumb basically is when you know that your uh, collection, and I call collection anything which can store multiple elements in the same variable. So when your collection is potentially expanding or shrinking, you should consider using list or a similar auto expanding or shrinking structure. If it's not, if it's fixed size, you should use an array, because it is as simple as it gets, and it's in most cases enough. And for performance reasons, and for performance reasons, uh, it is the fastest of them all, as it is the most primitive. Right. So in this example, you create a list just like array with a new keyword, with anything really that that has a reference. So I forgot to mention, array has a reference. So uh, we create a list of numbers or an array of numbers, and then if we pass that to a method and manipulate it inside without changing the reference, then those changes will persist. Like we can load elements of array in a method, and we don't need to return that array or a list, because it's passed by reference, meaning that the changes will persist, that we work with a copy of a reference. Alright, so we created a new list in this example, a list of int, and that's our generic type. And we add first element to our list, which is 1. And then we assign a value of the first element of our list, which is 1. And to get a count of total amount of numbers in the list, we use a count property. Note that count is a property and not a method, because list is smart the way it does with the count, because whenever you add, so when you create a list, the count is 0. When you add a number, sorry, a single element to a list, the counter will be incremented through the add method. When you remove an element, the counter will be decremented through that method. So the counter itself is not a method because it doesn't calculate anything. It doesn't iterate through the list to get the total number of elements. It constantly uh, updates the amount of elements it has based on through the remove and add methods. So the other examples of list methods would be you can remove an element by value, you can remove element by index, and it's a really, really nice thing. The third major structure for storing many of the same is a dictionary. Dictionary is literally what it sounds like. It translates a key and gives you a value. So it stores many key value pairs, and it's basically the same as list, except you work with, instead of a single many values, you work with pairs of values. Um, so when should you use a dictionary? And the answer is when integer as an index is no longer fitting, and when um, when using an index other than an integer would give you more meaningful results. For example, if I have a, a translations dictionary, I can bind two languages, and basically one language will be a key and another language will be a value. Word from one language will be a key and word from another language will be a value. So in this case, in this example, we created a dictionary which translates words from Lithuanian to English. So our first translation is labas, hello. And I terribly misspelled the greet, but no matter. Uh, so English greeting. Oh god, I made terrible mistake. I'll fix it. Greet. Right. So in this case, we added a translation. We translate labas to hello. So we add our translation just like in list through add method, and we remove. We get the translation just like we would get the first element of an array or a list. We get an element from a dictionary using a key. Our key is labas, and that's our native word. And the translation will be hello. So using a key, we get a value. First parameter in add method is key, and second one is value. So we added a key value pair, and by using a key, we get a value. Compared to a list, this has methods like properties like keys to get a list of keys. We have methods like contains. List has method contains too, to check if element exists in a list. When we call contains from a dictionary, it checks if a key exists in a dictionary. So that's uh, that's about it about dictionary. And now all of collections, literally all of collections, can be put into two groups, either I enumerable or I enumerable generic. All collections derive from those two classes. Those two classes, interfaces, those are interfaces. So those interfaces mean uh, that something can be iterated through. And if something can be iterated through, it means it stores more than one element in the same variable. And that's why when you want to simply iterate through elements, having a return type of IEnumerable is enough. And when you expose your methods to public, methods which return a collection, instead of returning a specific collection, you should prefer returning a generic collection, not a generic collection, but an abstraction of a collection. You should not enforce others to work with details of your collection. Because um, because uh, we would like the developer decide what is the best collection for him to work with. Uh, for example, if I need semantics of a list, I will convert my enumerable to a list. Or maybe if I need semantics of an array, I'll convert it to an array. It doesn't really matter, but if you have, let's say, a list which is returned, and then you convert it to an array, I think it's much more performance costing, and in some cases, for more complex collections, more non-standard collections, it doesn't really work that way. You can no longer convert, let's say, if you need sorted list, you won't be able to do that, and so on and so forth. So leave the choice up to the developer who will consume your code to decide what he wants to use, and don't enforce that upon him, and return those when it's public. Uh, also, for list versus array, um, if something is exposed to public, my rule of thumb is mm, to make that as a list by default, or as a list by default, because not a return type, but a field or a property. If it's well, a property, a field will not be public. So if a property is array, it's quite bad because you don't know what will be the need in the future, if it will need to expand or not. So by using a list for something which is exposed to public via a property, you ensure that um, you will be able to expand the amount of elements that you have or shrink the collection. So uh, it's more safe that way, and it doesn't really uh, contribute that much to performance compared to an array. If you're really heavily relying on performance, and if you really know that the requirements will not change, then array is fine too. But just the default case would be a list over array, unless the scope is local, like local and not changing. And now, how do we use collections and loops? Well, first about loops in general, and I forgot to mention one more loop, which I will demonstrate soon. Okay, so basic structure of a loop is that it needs to have a condition for the loop to stop. So every loop will have a condition somewhere inside them, which will tell them which will which when it evaluates to false will stop the loop. So loop executes same commands which are put inside the loop for as many iterations as the loop runs, and loop can be stopped internally without using the condition, but that's a bit of a dirty way of doing it, and we'll demonstrate all of it right now. So the first most simple loop is a for loop. So you have your initial value set, for example int equals 0, and then you have a condition. For loop, the condition usually is related to first and third statements of the definition for loop. So your initial value, the parameter which holds the initial value, will need to be compared probably to max counter or something like that. So let's say if I want to run my loop 5 times, I will say that my initial value is 0. Let's say index int index is 0, and my condition index is less than 5 if I want to run it 5 times, and then my uh, change in every iteration will be that my index changes by 1. So index plus plus. And running this, it will execute whatever is in between the curly braces 5 times. While is a bit different because it it doesn't need to have initial values, and it doesn't need to have a change. It doesn't have to, more like. And what this means is that it runs as long as the condition is true, and you change condition inside the loop, inside the while loop. So with this comes a little danger, because mm, there is no restriction for writing something like while true. And while true is a danger because it can often cause no stack overflow exception, because it can run infinitely long, because there's no condition to stop the loop. So your application will never leave this function, and it will simply reach a dead end. Dead end for never stopping. Uh, that's why, and the only way to stop while true is breaking it or returning from it inside the loop. So it's not recommended because programmers tend to forget that or mess it a little bit, and that little bit is enough to cause stack overflow exception. And last one we have do while, and essentially do while is um, very similar to while, except it will execute some line of code once always, and then check the condition after executing it once. That's the difference. It's a rare case, to be honest. I don't really use this one, but sometimes you want to always execute something at least once and then keep repeating while the condition is true. A rare case, but a possible case. So in this example, we would execute whatever is in between do only once because our condition is false. So how do we exit a loop? Uh, 3 ways other than the default way, the natural way, the normal way, through the loop exit condition, we can exit it through internally through break and return statements. Return statement is in general uh, returning to the point where the function was called from. So it's not really native to loops. It works everywhere. Uh, so with return you can exit from anything, from any function, loop or not, it doesn't matter. So we have two examples. The first example uses a break keyword. What break does, it basically stops the loop from running and will continue to the next line there is. So in our case, it will not execute anything except conditions 2 line, because switch test will be skipped as I break before it. Condition will not be checked because I already left the loop with the break statement. So conditions 2 is the thing that will be executed. For the example on the right, we leave a function immediately when entering the loop, and it will execute nothing. It will just go to the point where this function was called. So that's the difference between exiting loop with break and with a return. Neither of them is recommended, as you would want loop to exit naturally with the loop condition. Uh, of course, there are cases when you need this, but you should always prefer loop condition. So, like I mentioned, when you have a loop, ensure that condition will eventually evaluate to true. The leave condition will eventually evaluate to true. So that means that the run condition will be false eventually. And that's why while true is a bad thing to do, because you are saying that you are enforcing your loop to be broken, to be left from within itself. So you will have to use either a break or return statements. So you're forcing someone who reads code to go inside of the loop just to know where and how it stops. And when you have the loop condition used, you will see where the loop ends immediately, and that's unless it's a do while. So it hurts readability having while true, and it is a potential danger. Written it. So uh, since we have collections, I'll add this to the slides as well. So since we have collections, let's create a collection. Um, let's create a list of strings, and let's add two elements to it. I'll use the names of whoever typed in chat, Ximbu and Cringine.
Kazan, it looks as if your screen is off. Like I cannot see anything.
My screen is off. Really?
Yeah, I'm getting a Twitch machine got unplugged. Try again in a moment, and the error code is 2000. That's what I'm seeing on my screen right now.
Mm-hmm. I see my internet jumping, the upload speed jumping from 10 kilobytes, 0 kilobytes to 2000. So I think that's why. It's my internet being unstable.
Okay.
Uh,
Okay.
um what can I do? A moment. I have USB tethering on, and it jumps ridiculously.
Yeah, I think it's back now. Can see it.
Okay, because it jumps to 6,000 even. It's like, what the hell? Okay, so we have a list. Let's call it names, viewers, and the third, fourth type of loop is a for each loop. And for this one is interesting because you are saying for each means you're iterating through all collection. So when you want to iterate through all collection and uh, uh, and work with elements of collection, like with specific each element of collection, you have a for each loop. So you have var. Well, I always write var. Var is uh, let compiler decide what the and we can print their names. So we can say that viewers are there. So we print the names of each viewer. Uh, One thing to note about for each, that you cannot modify a collection you're iterating through, and uh, that's because you will make it much more harder for runtime to understand what's going on with collection. You're iterating something which is changing, so it no longer can iterate through it. So it will give you an exception that you cannot modify a collection which you're iterating through. So something like this, removing the first element. Uh, is it the first? Yes. So removing the first element, it will give you an exception because you're iterating the viewers. You cannot do that. So if you want to make changes for this collection based on, let's say, conditions or elements of this specific element, let's say if a viewer is Ximwu, I want to make two of Ximwus instead of one, or I want to convert his name into Bob Ross, then I can convert his name, but I cannot um, uh, mutate my collection. It's immutable while I'm iterating it. I can change elements. I can do this if viewer is I can mm, well, with this one I will not be able to change the value of viewer as well, because it returns me a value which is not associated through a reference. So by doing this, it will not work. And we have for each iteration variable viewer is immutable, exactly. So there is no point doing this, as this is a value and this is a reference. So by changing this, we change it locally and we don't really do anything with it. So you cannot change for each variable which returns through a collection. because it's immutable and it's not associated through reference. If it was an object, I could, of course, uh, run a method, change some properties, but I wouldn't be able to change a reference. So that's the key point for a for each loop. And if we run our program and do a for each test, this is not our program. This is not our program, or is it? No, it's not. Uh, it should be. Where is our main? At right, right. Mm, let's find our entry point. Presentation console at. Where was the main? Entry point, entry point, entry point, entry point. Oh, where do I set it? Because I cannot find it. Resources, settings, signing, security, publish. Doesn't ring a bell. Mm, it should be here. I just don't know. Program CS static. Right. This is even kind of misspelled. Well, anyways, let's public static void main array of string args, and it should be in a class called program. Though I think what caused this to be like this is the name of namespace console. You should avoid keywords in namespaces, and that's why it's probably causing those things. So if I do greeter, it's not greeter. Where is it? It's in person for some reason. I'll just rename this to testing. Yeah, to testing. And we have a for each test, which we want to run through testing. So testing, we run for each test. Right? Let's see if it works. I want to run this one. Let's see how it goes. Alright, so it caught the entry point. So we printed all our viewers in a for each, and that's it. So those are the types of loops. I was supposed to demonstrate something. I don't remember what. Do you have any questions?
No, I'm okay.
Okay. Okay, so let's demonstrate what happens when you want to modify element of the collection you are iterating. When you want to modify the collection you're iterating. So let's viewers. We will get a runtime error. It will not be a compile error. Right, remove at removes element at index. Remove removes element by value. Okay, so if we do this and now run, we get an exception saying invalid operation exception. Collection was modified and enumeration may not execute because you cannot modify a collection which is being iterated through. Right. Uh, there are sometimes difficulties. Now back to I'll create a new class just for the sake of being more clear. So sometimes it can be difficult to understand logical values, especially when you do multiple operations with them. So let's do it. Let's do logical operations test. We'll create a static class to play around with it. So let's create a static method which will logical test 1, which will evaluate. Actually, yeah, let's do it here. So let's do something like var predicate 1 is, and let's write a bunch of variables. So a is 0, b is 5, and c is true, and d is false. So if we do something like a equals b, or my keyboard, oh my god, where is the sign? God damn it. I still getting used to this new keyboard. Okay. So b equals a equals b or c and d. And a equals b or c and uh, and d or c. Would you take a guess what the result will be? Or in what order will it evaluate? Actually, let's make it more interesting. Right. Right. Okay. So what will the predicate 1 be? Do you have a guess? So the order is that it starts from the negation operation, I think. So this will be inverted. So this is true, and this is false. So I will mark those down step by steps. So this is true, this is false. And now we start from the start. So is A equal to B? That's false. Now we have this condition. We continue combining this condition with this condition. So false or true is true. So we combine true with true, we get true. And then we say true or false, it will be true. So my expectation is that this will be evaluated as true. So let's test it. Let's run it instead of that one. We called it logical logical operation test. Test, sure, test is good. Okay, go back. Okay, call it. Let's see what happens. I'll comment this out. Let's run. True. So I was correct. So just like in maths, you do the same things. Uh, let's make another test. Um, so let's, how do we change this? Or and to D. So let's remove those conditions and just play with trues and false. Uh, so we have bool T is true and bool F is false. So F and F will be false. Yeah, false. Um, will be false. Will be true. Uh, false and false will be false, and true is still false. True and false will be false. Well, by adding this, you basically say that it's gonna be true. So if I run it now, we get true and true. Uh, just like in maths, you can play with brackets, changing the rules of how it gets evaluated. So this will get evaluated first, which doesn't matter because it does that anyways. But if I go around it like this, I'll make this. Oh, I printed wrong predicate, by the way. Right. We don't need brackets, right? Okay. So we print 2 and we print 3, and this is 3 now. And if we run, true, true, false. It became false just by changing brackets. So it means that this is the same, so this bracket doesn't really matter. But this bracket is key because false, well, fuck. Now, okay, F, F and F, right? And let's run. True, true, false. So this bracket here evaluates it first instead of first evaluating this and then evaluating the result of this with this. Well, stacking everything all the way to the right. This evaluates this first. So by the time I come here, I don't stack it with this one, but I stack it with this one. I do operation with whatever is in the brackets. Okay, and to demonstrate the short circuit and not short circuit ifs, ends and ors, I will create a new class. I'll call it I'll call it uh, male. Well, person I already have human uh, logic. I'll just call it logic. So public class logic, and whenever it's a method, not what am I doing? Logic here, and this is void logic. This is nothing actually. So whenever I check for some condition, whenever I try to get condition of this logic, condition property, so public bool condition, uh, I will always return false here, let's say, but at the same time I'll print what I return. Calling check, right? So if I create two logics, logic class 1 is a terrible logic and condition, logic and condition. Okay, logic and condition. So new logic. Why can't I create it? Inertia mage, spell editor core. Okay, makes sense. Oh, let's see where this is. Logic is nowhere to be found, so Control N, put it somewhere that I have no idea where. I would like to have it there. So I'll just create again the same thing. Put the code there. Well, I want the namespace to be left. And save, call check. Alright, now we can do the same thing. Okay, new logic, and uh, L1 just for the sake of writing faster, and L2. L2 is not needed. So if I write predicate 4, and do L1 condition and L2 condition, and L1 condition, so false and false will give me false. So CV and predicate 4, and as opposed to 5 and 5. So the difference will be that in this case I will print the call twice, and in this case it will only be printed once. So calling check, I checked twice, and calling check, I checked it once, because left side was enough to evaluate if it's true or false. So I wanted to show what a jacked array is and a 2D array is, and what's the difference between the two. Array test. So let's write it. 2D array is written like this. Matrix and well, not matrix, but what would be a good example? What would be not a matrix? Um, 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 let's say seats. So this means and I can't, okay, so this means I will have five rows, and if I do this, oh, it's a class. I need a method. Public. This will be static. I don't want to create it. Public static void test 2D array. Comment says it all. I mean, name says it all. So if I do this, so my first row will contain 10 seats. My second row will contain 10 seats. Let's say it's aligned like an L shape. Uh, so first 3 rows will contain 10 seats each, and last 2 rows will contain um, uh, 30 seats. Maybe this is also 10 and this is 30. So you get like, let's make the number smaller to illustrate better. 3, 3, 3, and 9. So the elements will align like this. Actually, let's illustrate this in a for each loop rather than writing a comment. So var seat in seats, and I can't for each this, but this is problematic as it converts that into one dimension. Like I won't be able to work with dimensions, so I need to for this, not for each, even though I work with all elements, but I want the semantics of 2D. Var, so first is row, from 0th row, seats. Now, this is interesting because getLength is a method that you need to call when when working with 2D arrays or multidimensional arrays. And also uh, it starts from columns. It starts from columns. It starts from columns. Does it start from columns? Does it start um, from rows? I don't remember. So let's print this. Is it rows or columns? Public. Right, condition. Uh, column should be so it will continue while this condition is true. If I run, sure, and it gave me 5, so it means there are 5 rows. So it starts from rows. Okay, rows, rows, rows. It's the opposite of x and y because you would think that you start with an x, but you start with a y. The coordinates. Okay, and this is column. 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 Seats get length 1. So I want to draw this out nicely, and this is 9. So I will do a CV and print a star per element of uh, a seat, a row. So if I do this, we get an error because I don't know yet. Right, because I messed up. So it's an array of arrays, and get length is for jacked arrays. So what I actually had to do is to say that mm, uh, that this is a row, and I should have said that this is a uh, row index instead of rows, and that will be column index instead of columns. So we have row, which is element at row index of seeds array, 2D array, and we iterate through row seeds, and we want to print each element there, and this is not a jacked array, and getLength will work on a jacked array. We'll demonstrate it soon. So row dot length, and if we run it now, uh, out of bounds because mm, I think this one messed it up, as we don't have a 2D. So I wanted to write this, and for each new line I wanted to just write an empty line. So if I do this, we see an L shape from our array. So this probably could be a representation of seeds. This kind of layout exists. So when you have inconsistent rows, it is a good idea to use a 2D array. Now, when you have a nicely ordered, aligned with same dimensions arrays, you could of course write a 2D array, but we have jagged arrays as well. So jagged array. And the difference is we have a comma in between, and we need to set how many rows and how many elements per row. So let's do the same, very similar. 5 rows with 5 elements per row. And let's do a similar thing, but it'll be a bit different. So now with this, I already have my full matrix with zeros in it. So if I iterate through rows, I would say that to iterate through rows, I need to get 0th dimension length, which means rows, the y-axis. And if I do this, it means I'm getting columns, the x-axis. I don't know why is it inverse compared to the standard coordinate system, but so be it. So row index, this no longer works, as I don't need to access an array through array. This works. So I simply say that I iterate through each row and through each seed, and as I do, I separate them with an empty line. So if I run, I didn't run that one yet, so let's do it. Let's separate this with a uh, 2D array test 1, 2, 3, and done. And this is a jacked array test. And if we run this one here, array test this one, we will see that it did a similar thing, but a bit differently. So this is the difference between the two arrays, and jagged array essentially is a matrix, and 2D array is an array of arrays. And that's about it for this lesson. Do you have any questions? Okay, then that will be for today. Thank you for watching.